Hi, in this video, I'm gonna do a quick comparisons of the three models of the atom. The Rutherford model, the Bohr model, and the quantum mechanical model. All these three models try to help us understand about the structure of the atom with emphasis on the electron. It's actually not that easy for us to understand and be able to figure out where the electrons are surrounding the nucleus of the atoms. And the reason is because the electrons are actually really tiny compared to the size of the protons and the neutrons. And because they're so tiny, they do not obey the law of classical physics. And therefore, it's thus really difficult for us to learn and understand about the behavior of the electron. So each of this model right here is an attempt to explain where the electrons are. Now, as we recall from the previous lecture video that I discussed already on the Rutherford model, in this model right here, Rutherford basically say that the nucleus is packed with neutron and the proton. And overall, the nucleus is positively charged. And outside of the nucleus, that is where we will find this diffuse electron cloud right here. So this is a region of diffuse electron cloud. And within this diffuse region, this is where we will find the electrons. And the total charges of the electron is then exactly equal to the positive charge that make up the nucleus. So overall, the atom is electrically neutral. So that the statements that come from the Rutherford model. This model right here, unfortunately, it didn't work out very well because it failed to explain the arrangement of electron outside of the nucleus. And on the next lecture, I'll be discussing the Bohr model, and I'm going to quickly go over some of the statements from the Bohr models in this case before I dive into more detail. So on the Bohr model, Bohr basically said that electrons are actually found in the orbits. And when we do a comparison between the Rutherford model and the Bohr model, you can then see that now in the Bohr model, electrons are just not found just anywhere in this region, but they can only be found in this orbits right here. So each of this line circle right here represent an orbit, and in this orbit right here, that is where we will find the electrons. So that the electrons are basically orbiting about the nucleus, and in them, that way we'll find the electron. Now, so the nice thing about the Bohr model is that it introduced the idea of the quantized energy level in the atom. So each of this orbit right here is called a quantized energy level. Basically, it means that electron can only be in this orbit, but can never in between this orbit. So that's what the term quantized mean. Quantized means it has to be certain value to them, but can never in between the value. And the Bohr model provided a very reasonable explanation for the discrete atomic line spectra in terms of electronic energies. And we will discuss the atomic spectra in a little bit and how that helps supported the Bohr model of the atom. Now, so overall, we can see that this Bohr model right here, it basically kind of failed to thoroughly explain the arrangement of electron, because we discussed that there's actually a lot of data in the emission spectrum in which cannot be explained by the Bohr model, and it also failed to explain the chemical property of the atom as well. So yes, it is an advancement compared to the Rutherford model, but it still failed to explain and help us understand about the chemical property of the atom. And lastly, the last model that we'll be discussing here in this class is the quantum mechanical model. And here is a brief overview of it. So this model right here said the following: it's actually impossible for us to determine the exact location of an electron. They're not in the diffuse electron cloud and they're not in the orbit, but in fact it is impossible to determine the exact location. So everything is about probability. Now, so in the quantum mechanical model, we will hear this term probability right here quite often, in which that is say that we can only know where the electrons are most likely to be in, but we don't know them for sure. So everything is about probability. And so electrons are most likely to be found in an orbital. And this is where we'll be learning a new terminology called orbital. So orbital are basically regions outside the nucleus of the atom where we are most likely to find the electron. So basically, regions with high electron probability are called the orbitals. And the quantum mechanical model introduced 4 quantum numbers that are used to describe the location and the energy of the electron. And these 4 quantum numbers right here are basically really the heart of the quantum mechanical model. And our emphasis on the quantum mechanical model will be on understanding the 4 quantum numbers and how knowing them would allow us to describe the location and the energy of the electron. And overall, the quantum mechanical model is the most powerful model of the 3. And it has been tested to be true for the last 95 years, despite all of the research trying to disprove it. The more we disprove it, then the more we found it to be true. And in the end, this will be the structure of the quantum mechanical model, where we see a lot of dots right here. And I will explain this dot right here in the next several videos.